Okay, welcome to the June 2023 paper 2H walkthrough. Question number 1 is a standard fractions calculation. It is a show that question, so you must show all of the requisite steps. I'm turning the two fractions into top heavy fractions. I'm flipping the fraction that I am dividing by, so 6 over 5 becomes 5 over 6. You can cross cancel first and then carry out the multiplication simplified. It comes out as 3 8/9. Question 2 it gives us 3 out of the 4 probabilities, and we know for a discrete random variable the probabilities must sum to 1. So if I add the 3 that we do know and then subtract that from 1, we'll get the one remaining one. In this case comes out as 0.27 as a probability for pink. 200 times that 0.27 means we would expect it to land 54 times on pink. For question 3, because we have parallel lines B to C and A to D, we can use our, it depends whatever you call them, co-interior, interior, allied angles, whatever, the pair of angles will add together to make 180, the two angles on the left. And that allows us to construct a little equation we can solve to find x. It comes out as 23. And that allows us to find all 4 angles in this shape. The question wants us to state the largest angle. We actually don't know which is the largest angle until we found them all. So I add the 3 remaining ones to get the 3 we do know to get 259. Subtract that from 360 and we can work out that the 4th angle is 101 degrees. And so we have all 4 angles, the largest of which is 115. So I shall state that as my answer. Question 4, substitute the numbers in, be careful with your negatives. -3, value of -3 for x comes out as 8, -1 for x comes out as -2, then -4, -2 and 2, and plot those points. Just be careful, the scaling for the x-axis and the y-axis on this graph is different, but if you read them off carefully you should be fine. And then see if you can do a better job than I have of drawing a smooth curve that passes through all of these points. I did my best. I'm sure yours will be better. Okay, question number 5. The ratio of the number of 2p coins to the number of 5p coins is 1 to 3. So if I call A the number of 2p coins and B the number of 5p coins, then 3A would be equal to B. Then if we multiply the number of 2p coins by 2 and the number of 5p coins by 5, we know that that will sum to 85. If 5b is going to be the same as 15 lots of a, from that 3a equals b, we can substitute that in to form a little equation in terms of the number of 2p coins which we can solve. There are going to be 5 of them. Work out b is going to be 15, so there are 10 more 5p coins than 2p coins. Question 6, standard form. 7.6 times 10 to the 7 and 0.00054 for part B. Question 7, we know that the angle between a tangent and a radius is 90 degrees, and therefore we have 3 out of the 4 angles inside our quadrilateral, so we can subtract those from 360 to get 132 degrees. The angle we're looking for is the reflex angle, so subtract that from 360 and you get 228 degrees. Question number 8, compound interest. So we're increasing at 4% each year. That's a multiplier of 1.004. Cube it, because it's going over 3 years, you get 765. Kilometers per hour to meters per second, times by 1,000 to turn it to meters, divide it by 3,600 to change it to seconds, we get 7.5 meters per second. Question 10, it gives us some means, so we can work out the totals. 11 times 17 and 9 times 18 will give us those totals. And then it tells us afterwards they have a mean of 18.5. So we can times 18.5 by 12 and by 10 to get 222 and 185. And we can work out that one's gone up by 35 and the other's gone up by 23. And the difference between 35 and 23 is 12. Question number 11. We've got a nine-sided shape, a nonagon. We can take 360, divide it by 9 and double it, and that would give us the 80 degrees in the center there. The two angles on the side are going to both be, well, we can work those out. We know that the interior angle of a nonagon will be 7 times 180 divided by 9, which is 140, and split those, we'll get 70 and 70 either side, and you can see I've marked all the angles inside that shape. We can work out the exterior angle to be 40, and then the angle that forms a straight line from O to D to K will be 110, and deduce that that angle X must be 30 degrees. For question number 12, we've got ourselves a right-angled triangle. First thing I'm going to do is work out the angle BAD by doing inverse cos of 8/14. That's the adjacent over the hypotenuse. It comes out as 55.15. That's the whole angle there, BAD. If I subtract 38 from it, I get the angle CAD, the little angle on the lower triangle, which is 17.15. We have the adjacent. We want the opposite, so tan is opposite over adjacent. If I multiply tan of that 17.15 by 8, we'll get the opposite. Comes out as 2.47. A probability question, so 2/6 chance of it being red, so there must be a 4/6 chance of it being yellow. And then for dice B, it's 1 and 5, so 1/656, 1/656. To be yellow and yellow, well, it needs the first one to be yellow and the second to be yellow. When it's probability and it's an and, we'll multiply. 4/6 times by 5/6 is 20/36, which you can simplify to 5/9 if you wish. Question 14. RQP is 90 degrees because angles in a semicircle are 90 degrees. And PSQ is going to be 22 degrees, and we need to see that angles in the same segment are equal. We'll do it. Worth just learning your circle theorem rules. There's not many of them. Question 15. 32 to the power of 3 over 5, or the fifth root of 32 is 2, cube it is 8. 8 to the 15 to the 3/5 is 8 to the 9. 15 times 3/5 is 9. The negative power on B, flip the fraction, brings the 10x to the top, so it's 10x all cubed, which is 1000x cubed. Question C, a few legitimate ways of approaching this one. The one that I'm showing you here is by forging a common denominator across all three fractions in one go. Lowest common multiple of 3, 5 and 2 is 30. So we take the first fraction on the left hand side, multiply the top and the bottom by 10. It gives us 10 minus 20y over 30. Take the 4/5, multiply the top and bottom by 6. And then take the final fraction and multiply the top and bottom by 15. So 30y minus 15 over 30. Again, you have more choices here. I've joined together the two fractions on the right hand side, so I'm going to leave the 10 minus 20y over 30 on the left alone. Just be careful, you're subtracting a negative, so 24 subtract negative 15 is 39 there, so 39 minus 30y all over 30. Multiply both sides by 30, we'll get 10 minus 20y equals 39 minus 30y. I've brought the y's onto the left and the non-y's onto the right. Divide by 10, you get y being 2.9. Question 16, so we're dealing with direct proportion, so q is proportional to the square root of t. Turn that into an equation, we'll get q is equal to k root t. And then I had a look at the graph. You could choose a number of points from the graph. I chose to see that when t is 1, q is 3. That's the simplest one, but you could have chosen another one. Plug that in, 3 equals k times the square root of 1, therefore k must be equal to 3. And our equation therefore is q equals 3 root t. Part B, I'm not convinced this is the best way, but it's a way that worked that I was thinking of in the moment. We've got q equals 3 root t. I've rearranged that to make t the subject. Divide both sides by 3 and square. So t is equal to q squared over 9. Now, I've considered what would happen if I replaced q with 1.2q, which actually is increasing q by 20%. So 1.2q all squared over 9 would be my new value of t, or if you prefer 1.44q squared over 9. And what's changed? Well, we've actually multiplied by 1.44, which is a 44% increase in the value of t. So I'm reading off the 0.44, if you like, in the change that's happened. Question 17, it's up to you which way you want to expand it. You could take 2 out of the 3 fractions and expand them, any 2, expand those and then multiply it by the third. I've done the first 2 just because they're the first 2 that I looked at, and it expands out 3x cubed plus 34x squared plus 84x minus 72. For part B, I'm going to make e the subject, so get rid of the square root by squaring both sides. I'm going to multiply by ef minus d and expand in one go there, leaving me with e plus g on the right. I'm then going to bring the e's onto the left and factorize, and the non-e's onto the right. So the e's on the left and then factorize there, and then the w squared d onto the right along with the g. And then lastly, divide by the w squared f minus 1, bring that to the denominator, and we have an expression for e. E is now the subject. Question 18, just graph recognition. C is the sine graph, the negative reciprocal graph is f, and the cubic is a. Not much more to be said there. If you know them, you know them, or draw them if you didn't know them. For completing the square, so first thing I'm going to do is factorize out 3, so 3 lots of x squared minus 2x plus 5, and then complete the square with the x squared minus 2x. Expand out the 3, so 3 lots of x minus 1 squared minus 3 plus 5, and then simplify the minus 3 plus 5 to make a plus 2, and we have completed the square. Question 20, counters in the bag. Well, the probability of there being at least one red counter is 1 subtract the probability that there are no red counters. The only way of there being no red counters is if we pick a red counter 3 times in a row. So 3 12ths times 2 11ths times 1/10. Subtract that from 1, you get 290 220ths. Question 21, they have generously already set up the substitution for you. So x equals 3y minus 1. Don't be tempted to make y the subject to the second one and substitute that in, because you'll end up dealing with horrendous fractions. Substitute the x in straight away. Expand out 3y minus 1 squared and then multiply all of those parts by 2. Then we can collect like terms. Be aware we're now dealing with a 3-term quadratic. So 3-term quadratic, we're going to want to make that equal to 0. It's how we solve quadratics. I spotted here that everything's divisible by 3, so I simplify my quadratic and then factorize. If you wanted to use a formula or complete the square, you can do, but you must show that you are using a legitimate technique, because it says show clear algebraic working in the question. Anyway, full factorization there. So y is minus 3/7 or 1, x is minus 16/7 or 2, and those solutions come in pairs, so I'm going to pop them in a box. Question 22. So we've got a 3D shape in front of us there, because the flagpole BF, that's coming out of the ground. That's a triangular thing in front of it. I've drawn BD. There, that's at right angles to AC. We want to find that length BD, because that's the length we're going to use to find the angle of elevation. So this is all about finding that length from B to D. D is the point where that line, there you go, I've drawn a D in there. First thing I'm going to work out is the angle BAD. Well, we have 3 lengths and we want to find an angle, so we're going to jump into the cosine rule. I've used the version of the cosine rule that has cos theta or cos A as the subject, and so I'm jumping straight into doing inverse cos of that to find the angle. B squared plus C squared minus A squared over 2BC. Plug that into your calculator, you get 41.4 degrees. That's my angle BAD. Once we have angle BAD, it's using another little bit of trig. We can find that length B to D. We've got, because we have a right angle triangle, we've got the hypotenuse, we want the opposite, so I'm going to use sine. Sine of the angle will be the opposite over the hypotenuse. So if I do 9 times sine of that angle, we will get the opposite. It comes out as 5.95. There's my length BD. We know the height of the flagpole is 10, so we can use one last bit of trig to find this angle BDF. That's the angle of elevation. Tan of the angle will be the opposite over the adjacent. So inverse tan of the opposite over the adjacent, inverse tan of 10 over my 5.95. Remember not to round part way through a question. Use the answer function on your calculator. Okay, question 23. We have ourselves a cuboid. We have lengths xx and 2 root 5 minus 3. We're given the volume as a surd, and so we can construct an equation for the volume. The 3 perpendicular lengths multiply together, x times 2 root 5 minus 3 will be equal to 13 plus 6 root 5. This question is very much about playing about with surds. So the first thing I'm going to do is divide by 2 root 5 minus 3. And then to rationalize the denominator, I multiply by the conjugate pair. That's going to be 2 root 5 plus 3 over 2 root 5 plus 3. That's a fraction equivalent to 1. And this will give me an expression for x squared. So to carry out the fractional multiplication, essentially I'm expanding a pair of double brackets. It does say to show my working carefully, so I'm being careful not to make too many big steps at once, otherwise I risk losing marks here. Once you've expanded out the double brackets, we can collect the like terms and simplify the fraction down. Everything's divisible by 11 there, so x squared will be 9 plus 4 root 5. Now it's quite an interesting question here. They've not asked this sort of question on any previous GCSE papers, so it's an interesting challenge. There might be a few ways of doing this. The way I've tackled this one is to say that a plus root b, that's the value of x, that squared is going to be equal to 9 plus 4 root 5. I expand out a plus b all squared, and then I join the bits that involve the square root together and the bits that don't together and kind of pair them up. So a squared plus b is 9, and 2a root b is 4 root 5, and from that you can deduce that b must be 5 and a must be 2. Therefore, a value of x is 2 plus root 5. Very tricky step there. Well, I don't know if you got it. Question 24. This is one of those questions where I do a horrendous drawing of a kite and then play about with it. So we've got our kite A, B, C, D, where A, B and AD are equal, and B, C and C, D are equal. It gives us A minus 210, it gives us B minus 27 fifths and 4, and C is 4, negative 5, and we have to work out D. Essentially what I'm going to do with a bigger picture is I'm going to find this point M, which is the intersection of the two diagonals, by constructing lines through BD and through AC and solving them simultaneously. I can find the midpoint of the line BD. Once I have the midpoint of the line BD, I can work out a vector that takes me from B to M, and then just add that same vector to M, and it will take me from M to D. So I'll start with the line AC to find the gradient, changing y over changing x, or y2 minus y1 over x2 minus x1, whatever you prefer. That gradient of AC is negative 2.5. Using y equals mx plus c or otherwise, we can find the equation of this line. A passes through A and C. I substituted in the coordinates of A into y equals mx plus c. You could have chosen C and you'd get the same line. Anyway, y equals negative 5 over 2 lots of x plus 5. That's our line passing through AC. For the one passing through BD, we know the line going through BD is perpendicular. So we're looking at the negative reciprocal of minus 5 over 2, which is of course 2/5. And then we can construct the line using y equals mx plus c again. We know it passes through the point B, so when y is 4, x is negative 27/5. Substitute that in and solve the equation to find c. C comes out as 154 over 25. And so the equation of the line passing through BD is y equals 2/5 x plus 154 over 25. Okay, so we have the equation of the lines passing through AC and BD. To find the intersection of those two lines, we can solve them simultaneously. So I'm going to rearrange them into a nicer form. I'm going to multiply the line passing through AC all by 2 and bring the x part onto the left-hand side, and I'm going to multiply the line passing through BD by 25 and also bring the x onto the left-hand side. And we have our simultaneous equations set up. I'm going to take the first equation and double it, and then and then add that to the second equation. So if you like, equation 2 plus 2 lots of equation 1, and we'll get 29y, because it's 25y plus 2 lots of 2y, is equal to 174. Y is therefore 6. Substitute 6 back into either equation, whichever one you fancy, and you'll get x is negative 2/5 once you solve it. And therefore we have the coordinates of the midpoint of the line BD, which is negative 2/5, 6. To find the vector that takes us from B to M, you can either think about it, or you can do the difference between the x coordinates and then the difference between the y coordinates, whatever you prefer. It comes out as 5,2, and all that remains then is to add 5,2 to the point M, and that will take us from M to D, and that comes out as, well, negative 2/5 plus 5 is 23/5, and 6 plus 2 is 8. So our point D has coordinates 23/5, 8. Okay, question number 25. So this is an upper and lower bounds question. We're given information about a sphere. we have density, mass and volume going on. So density is what we're trying to calculate here. We want the upper bound for the density. So density equals mass over volume. The volume of a sphere is 4/3 pi r cubed. So here we're going to have density is equal to the mass divided by 4/3 of pi times by whatever the radius is cubed. Writing the upper and lower bounds for the mass, and then the upper and lower bounds for the radius, where the upper bound for the mass is 265, the lower bound for the mass is 255, the upper bound for the radius is 285, and the lower bound of the radius is 2.75. Now we have to work out which one of those we want to use. We want the density to be as large as we possibly can get, so we want the upper bound of the density. While the mass at the top, we want that to be as large as it can get, so that will be the upper bound of the mass. And then for the radius, well, we want to be dividing by something involving the radius. We want the radius to be as small as possible, because we want to divide by the smallest number we can to give the largest outcome. So I'm going to take the lower bound of the radius, and then I'm going to substitute my values for the upper bound of the mass and the lower bound of the radius into the calculation. So 265 pi divided by 4/3 times pi times 2.75 cubed, and that comes out as 9.5567. Rounding to 9.56 to 2 decimal places. All right, well done.